Software testing, practical approach. We've studied basic concepts of software testing at the theoretical level. Now we're going to start understanding about the practical application of these concepts at the software project level. At the end of this lesson, you will have learned about software testing documentation, the software test plan, software test strategy. You're going to take a look at a test case and salient features, and the techniques of test case designs, and software testing results, the reporting, and software test automation, the decision for automation, and software testing automation tools. Let's begin. Since we're now aware of the detailed aspects of software testing at the theoretical level, now we need to understand the process of software testing. Software testing is a structured process of finding defects in the software system before delivering it to the final customer. This process is a bit complex and involves risk as it deals with the quality of the end product, and in turn that would reflect the brand image of the company delivering the software system to the marketplace. So, typical software testing involves various processes as well as documentation. The basic level of testing documents are the software system requirements and the specification document, the software specification document, the business level, the technical level, and finally the software design document. These documents are foundation level documents, as they're important for the preparation of the lower level documents like test cases and test strategy. We're going to discuss all of these documents in detail in the next slide. Let's look at the typical software testing documents, which can be used at the testing team level. This is material that provides information about every phase or activity of software testing. The common input documents for software testing purposes are the test plan, the test strategy, and test cases and test data files. After performing the software testing, the final output document is the test results document. Also, test release criteria need to be prepared if needed. Some may feel that software testing documentation is a redundant activity, but let's see why this documentation is needed. Software testing documentation helps in tracking the progress of the overall testing process. It proves to be useful as guidance in cases of any deviation from the standards. In turn, it's useful in managing the overall quality, as well as timeline of the testing activity. So, we can say that software testing documentation is a useful activity. Let's take a look at the plan. The software test plan explains the various facts and figures about the testing project, like the project introduction, which is a formal listing of details like the name of the project ID, the number of modules under the project, brief client details, the business scope, etc. The objectives and tasks include details of the testing project goals and various tasks to be performed. The next item, which is optional, is software test strategy. This can be attached in the test plan if necessary. The high-level functional and non-functional test scenarios, which include a brief introduction of the functional and non-functional test services, and also the automation details, which should include the need for the automation, resources like testing tools, and expertise needed for test execution. The next item in the test plan is the plan to manage the test cases during the testing phase. It should also suggest the use of tools for testing automation. Hardware requirements. The test plan should list the required server, operating system, front-end and back-end details, the testing tools, if any, and browsers to be used if the application under test is web-based. The features to be tested should include a brief description of the functionality under the test. The features not to be tested is a brief description of the functionality which is not to be tested. This section should describe the valid reasons for non-testability of the features. The schedule of the testing process should include the detailed project plan, which mentions activities to be performed, the start date as well as the end date of every project activity, and the number of resources working. Generally, the project schedule is prepared using standard software like Microsoft Project. The risk, if any. Last but not least is a listing of the probable risk in the project. This should mention the risk and the evidence if possible. This will help the customer and the testing team managers to mitigate the risks. Let's take a look at the strategy. Now that we've gone over the test plan, now we're in a good position to discuss the test strategy in detail. Sometimes the client wants the test strategy to be prepared as an independent document instead of merging it in the test plan. Sometimes detailed and separate test strategies helps in a better product management for the client business managers. So let's click on each of the boxes for details. The test strategy includes, number 1, the project introduction. That's a list of the name of the project, the client, and the scope. Number 2, the key stakeholders. That means the people involved in testing activities from the beginning. Normal stakeholders include the testing team members, the test analyst, the test team managers, the business analysts, and development team members. The typical stakeholders can be classified as client level. That'd be a vendor who's testing the project. This is already discussed in the slide for stakeholders in software testing. The next item included in test strategy is the types and levels of testing to be practiced, like unit, integration, system, and user acceptance testing. The test strategy should include special testing like performance testing if needed. The test strategy should also explain the detailed time estimate for the testing work to make planning easier. It should also include the list of the software testing tools to be used. Test strategy is extremely beneficial for project management of the testing project. It declares the testing goals of the project well in advance. It's a guide for tracking the progress of the project. It serves as a guideline in case of any deviations of time, cost, quality of actual project from the planned parameters, etc. Test strategy is the document which explains the testing approach in advance. Test case, salient features. Now, let's take a look at the test cases as a software testing concept. Test cases is a written command which can be executed on the software system in order to find out if there are any defects. Let's take a look at the meaning of an ideal test case. An ideal test case should reasonably find an error or defect in the software system. It should not be repeatable in terms of functionality, data, or the system behavior. An ideal test case is neither too simple that it's not enough to drill the software functionality, nor is it too complex to manage and execute. The ideal test case must try to test all of the paths for finding the errors, in other words, the condition testing, the coverage testing, etc. Lastly, an ideal test case is helping in finding a faulty functionality developed which may have failed during the program or the logic steps. All right, the next few slides are going to explain different techniques to design good test cases. Sit back. Now that we know what is meant by an ideal test case, we can start learning about the various techniques of developing the test cases and data to be used as an input during the test case's execution. The first technique is equivalent partitioning. This technique mainly focuses on data preparation, which is useful in functional software testing. Input data can be divided into various categories. This technique divides the data into two groups, valid and invalid. The various scenarios of this technique are the test data used as a range, 1 valid and 2 invalid, for example, an age group for school admission, or the test data used as a specific value, 1 valid and 2 invalid. For example, a student ID for school. Test data can also be used as a member of a set, 1 valid and 1 invalid. For example, a specific student of School A but not for School B. Finally, the test data used as a Boolean value, one valid and one invalid. An example would be a student exam result is either pass, P, or fail, F. The next technique of test case design is boundary value analysis. It's commonly known as, you guessed it, BVA. In general, chances of any software failure are more at the boundary conditions. Under this technique, the input data for software testing is prepared so that it spills on either side of the normal range. So, if an input condition specifies a range bounded by values A and B, the test cases should be produced with values of, say, A and B, just above and just below A and B respectively. For example, for the field commission, if the ideal range is 10 to 15%, then the test value of this field would have values like 9% and 16% for boundary value analysis. Now you can understand how to develop test cases for effectively finding defects. If the input data spills on either side, then a proper user-friendly message should be populated by the system instead of any exception. For example here, if the commission is suggested as 20%, then the system should show a user-friendly message like commission should be in the range of 10 to 15%. The final area in software testing includes the software testing results reporting. The test result is the normal outcome of the testing process. For example, at the end of testing of an online purchase order management system, the tester is recording various aspects of the testing process, like the test execution status, the number of test cases executed, the test cases passed, the test cases failed, the defects found, the mapping of the defects with the test cases for more clarification. Also, if some of the software functions are not tested, they should be highlighted as the reasons for non-testability of the software, or the issues in test continuation like data problems, unclear requirements, etc. These issues may be in the status of resolved or unresolved. These issues need to be addressed while submitting the final software version after completion of the software testing. This includes retesting of the further version of the software or totally ignoring the issue. The decision is totally based on the client. Finally, we get to automation. We're going to take a look at a new era in software testing. Automation. The software testing done with the help of the automatic testing tools is known as automated software testing. Automation testing helps the testing process in various ways, like increasing testing speed and improving testing efficiency. It also improves the accuracy in testing. If retesting is the scope, then automation would save time and money. Various testing tools are available to perform the automated software testing. Leading vendors of these tools are HP and Mercury. Some of the testing tools are HP QTP and HP LoadRunner. Let's look at some of the reasons why we would do this. Major cases for test automation are repeated test execution of the same test cases, huge data generation for testing, and even 24-hour test executions. Testing for huge load or scale in terms of users, data, etc. Now you're going to learn about software testing automation tools. Let's go over the various tools that are available for the software test automation. Of the variety of tools available, common tools for test automation are the HP Quick Test Professional, and commonly known as QTP, or the HP LoadRunner. These tools can be used towards test optimization in terms of time and cost. For example, QTP can be effectively used when repetition of the functionality is to be tested. Also, QTP is extremely useful when similar functionality needs to be tested within different data sets. Now, load runner is used when an application is to be tested for huge data loads, and if the application is to be accessed by multiple concurrent users, users at the same time. It's important to use the correct testing tool for the testing scenario. All right, in this module, you've learned about software testing from both the theoretical and practical approach. You've also taken a look at software testing's life cycle and the stakeholders in software testing. Don't forget the system development life cycle, or the SDLC models, the quality assurance and control, the software testing documentation, the techniques for test case design, the software testing results reporting, and finally, the test automation decision making. Congratulations, you've completed this module. I'll see you in the next one.